Hello everyone, this is question 5 from Mechanics 2023 for Edexcel. So I've got a projectile question. So it says a small ball is projected with a speed of 28 meters per second from a point O on horizontal ground. After moving for t seconds, the ball passes through the point A. The point A is 40 meters horizontally and 20 meters vertically from the point O as shown in figure 2. The motion of the ball from O to A is modelled as that of a particle moving freely under gravity. Given that the ball is projected at an angle of alpha to the ground, use the model to show that t is equal to 10/7 cos alpha. Now the first thing I would say about projectile questions is really there's only two tools available to you. You can pretty much just resolve vertically and resolve horizontally. Okay, so that's literally, if you're stuck with knowing what to do on a projectile question, it's going to involve resolving vertically and resolving horizontally. So let's just start off by resolving horizontally and let's see what happens. So I've got my sketch here. We've got alpha there. They give us this point here. Now when they give you a point there and they tell you the horizontal and the vertical distance, that usually involves that you have to find an equation in the horizontal and an equation in the vertical and then somehow combine them. The other thing that's worth noting is very often in questions they'll tell you, say for example, that tan alpha is equal to something over something. But they haven't done that in this particular question. So that's a little bit unusual, and we'll cross that bridge when we get to it. But first of all, let's resolve horizontally. So there's our old speed, distance, time triangle. You might remember possibly from year 8 or somewhere around about then. We want to find the distance, and distance is speed times by time. So the distance, we know the distance is 40 because we're given that in the question. The speed is 28 cos alpha because we're resolving horizontally, and the time is t. So just rearranging that gives us t is equal to 40 divided by 28 cos alpha. There's a common factor there of 4, which gives us 10/7 cos alpha as required. So that's part A done for a couple of marks. Quite nice there. Okay, part B, show that tan alpha squared minus 4 tan alpha plus 3 equals 0, and it's 5 marks. So again, we've resolved horizontally. All we can do now is resolve vertically because that's the only thing we've got available to do. When we resolve vertically, we're going to be thinking about a suvat. And the reason we think about a suvat when we resolve vertically is because we have a constant acceleration. And the constant acceleration is the acceleration due to gravity. But remember, when you resolve up, gravity is working against you, so you treat gravity as being negative. So it's going to be minus g. Okay, so for a suvat, you start off by writing down S, U, V, A, and T, or I do anyway. And then what's our S? Well, the vertical component of the distance is 20 meters. So we can say that 20 is equal to, and the vertical component of the velocity is 28 sine alpha. Okay, so we've got 28 sine alpha. V, we're not worried about how fast it's going. Acceleration is minus g, and the time when it goes through the point A is that time t. Okay, now notice we've got two equations here. We've got one for t being 10/7 cos alpha. Okay, so this is at the point where the ball is going through the point A. And we've got another equation here for when the ball is going through the point A as well. And you'll notice that the equation that we're asked to derive has no t in it. So therefore, we're going to be subbing this equation into our suvat equation, okay, to eliminate t. So let's carry on with this suvat though. So we're looking for S equals ut at half at squared because we're not worried about v. The horizontal is 20, our u is 28 sine alpha. There's our t, and we've got a half times minus g times t squared. So we've got two equations now, and we're going to sub in that equation into this equation. So let's do that. So subbing now what I've called equation 1 into equation 2. And you can see the t has been replaced by 10/7 cos alpha and 10/7 cos alpha squared. Okay, so let's work this out then. So when you work out 28 times 10 divided by 7, you get 40. And when you work out this one, it's going to be a half of 9.8 is 4.9. And we're going to have 10 squared over 7 cos alpha squared, so that's 100 over 49 cos squared alpha. So working out 4.9 times 100 divided by 49 gives us 10, and 1 over cos squared is sec squared. Now this is important because this is what we're going to use to get the quadratic in tan, because sec squared is 1 add tan squared. So now we can basically write this as 20 equals 40 tan alpha minus 10 times by 1 add tan squared, expand our bracket, that's minus 10 tan squared. Take the whole thing over to the other side, giving us 10 tan squared minus 40 tan alpha plus 30 equals 0. We've got a common factor of 10. Dividing everything by 10 gives us tan squared alpha minus 4 tan alpha plus 3 equals 0 as required. Okay, so that was pretty nice. So basically we just resolved vertically and resolved horizontally. We got two equations. We observed that there was no t in what we were asked to derive, so we used that to substitute one equation into the other. Now, this next bit I think is a little bit intriguing and a little bit unusual. I haven't seen this come up very often in questions, but I'm glad it's here because it makes us think a little bit. It says, find the greatest possible height in meters of the ball above the ground as the ball moves from O to A. So in other words, we want to know what this height is here, the greatest height there. Okay. Now, usually what we would do, the normal approach, is we would just resolve vertically. Okay. We'd write down our suvat, S-U-V-A-T, and we would basically be saying that the V is going to be 0 at the greatest height. Okay. And that would be like our normal approach. But the problem that we've got is we haven't been given that key piece of information where, at the start of the question, where they say something like tan alpha is equal to 3/4 or something like that. We're missing that piece of information. So because of that, when we resolve vertically and we write u sine alpha, at the moment, we've got no way of knowing what u sine alpha actually is. So that's problematic. So we need to think a little bit more deeply about what's going on here. Well, we have this quadratic in tan. Okay, now what's the significance of that? You may remember that with projectiles, there are two different angles of elevation that would cause the projectile to pass through the same point. So I've illustrated it here. There's a steeper value for alpha, and there's a more shallow value for alpha that you could have. And you can see from this sketch that I've put here, both of those different values of alpha are going to cause the ball or the object to pass through that same point A there. So we've got to solve this quadratic in tan alpha, okay? So it factorizes into tan alpha minus 3, tan alpha minus 1. So tan alpha is 3 or tan alpha is 1. Reversing that tan, it gives us, taking the inverse of the tan, gives us alpha is 71.6 or alpha is equal to 45. So those are our two possible angles. Now, I think you can see from this sketch, in order to achieve the highest height, we're going to need the steeper of those two angles. So therefore we can say that we're going to go with the tan alpha is equal to 3. And this is the key that we've now got for working out our angles, okay? Because if tan alpha is 3, we can now construct one of those little triangles like we normally do. So we're going to say tan is opposite over adjacent. So it's tan alpha is 3, so it must be 3 over 1. So our triangle must be 3 squared add 1 squared square rooted is root 10. So therefore we now can find out what sine alpha is, and we can find out what cos alpha is. So now we're back on track with the original approach, because we can now resolve vertically, use a suvat, set the v equal to 0, and we're all good for the u now because we've got an expression for sine alpha. So let's do that. Let's do it's back to business as usual. Now we've done that little bit of an extra kind of like had to think about it there. Okay, so we're resolving vertically now. And what have we got? Write down suvat. We're trying to find the maximum height. Our u is 28 sine alpha, v is 0, a is minus g. We're not worried about how long it takes. So the appropriate suvat is going to be v squared equals u squared plus 2as. So that gives us 0 squared is equal to 28 times by, now notice I've put in there my sine alpha, 3 over root 10, plus 2 times minus 9.8 times s. So there we go. So that's our u sine alpha, and it's all squared. Okay, working that out, we find out that s we've got everything, all these numbers are all known. So when we put that into our calculator, that gives us s is 36 meters, and that's that one done. So yeah, even though that was only worth 3 marks, I think that's one of the trickiest parts in this question for sure. Okay, now the last bit, it says the model does not include air resistance. State one other limitation of the model. So there's lots of things we can have, a variety of things we could have. It's not taking into account the spin on the ball, that would affect things. It's not taking into account the physical dimensions of the ball, because the ball is being modelled as a particle. And the ground might not be horizontal, which obviously would affect how far it would go as well. So any one of those 3 would be acceptable for another modelling assumption. Okay, I hope you found that helpful, and I'll see you in the next video.